Hello everyone, I am NDPA Naula under the registration number 4086 and I will be starting off this conference web presentation on behalf of Group 48. This is the overview of our presentation. Our presentation today covers the conference paper titled Virtual Nexus Enhancing 360-Degree Video AR/VR Collaboration with Environment Cutouts and Virtual Replicas. This paper was presented at the ACM UIST 2024 conference held from October 13 to 16 to 2024 in Petersburg, USA. The work was conducted by this research team from the University of British Columbia, Canada. As of today, the paper has been cited fewer than 10. Let's talk about the core problem this paper addresses. In remote collaboration using AR/VR, we often face a trade-off. On one hand, 360 video offers high visual fidelity. It looks great, but users can't really interact with the environment. On the other hand, 3D reconstruction lets you interact and manipulate objects, but the visuals are often poor. This trade-off limits effective collaboration. For example, a remote user might clearly see a space but can't manipulate objects meaningfully. The motivation behind Virtual Nexus is to combine the strengths of both visual fidelity and interactive realism in one seamless system. With that, I will now pass it on for the next section of the presentation.
Let's now look at the research objectives that guides this work. The main goal of this paper is to enhance immersive AR/VR remote collaboration by bringing together the best of both worlds, the fidelity of 360 video and the spatial interactivity of the 3D environments. But this raises two important research questions. How can VR users interact with high precision inside a 360-degree video environment that traditionally lacks depth perception or interactivity? How can local AR users and remote VR users collaborate as if they are physically co-present in the same space? To address these issues, the authors propose three key contributions. First one is environment cutouts. These are like miniatures sliced out of segments of the 360-degree scene that VR users can pull towards themselves and interact with. Think of them as world in miniature views that preserve detail, allowing precise interaction. The second one is virtual replicas. Here, physical objects from the AR user's real world are scanned and reconstructed using a neural rendering method called Instant NGP, enabling VR users to interact with accurate 3D models. The third and final one is the spatial synchronization. This system keeps everything, annotations, hand pointers, and objects perfectly aligned in both AR and VR spaces, allowing real-time collaboration. Together, these contributions allow AR and VR users to share, explore, manipulate their environment in new, intuitive, immersive ways. Now, let's look at the system, how it's actually built. The Virtual Nexus system architecture consists of four core components. First one is an AR user using HoloLens 2, who interacts with the real physical space, captures both spatial mesh and RGB data. The second one is VR user on MetaQuest 2, who receives the live 360 stream and uses environment cutouts for interaction. The third part is a 360-degree camera, specifically the Insta360, positioned in physical room to stream panoramic video in real time. And the fourth one is the powerful central server equipped with NVIDIA RTX 4090 GPU that handles all the streaming, real-time 3D rendering, and the neural reconstruction using Instant NGP. The communication between AR and VR clients happen over a shared Unity project. The system uses foveated video streaming to reduce VR rendering load, QR code-based calibration for precise spatial alignment, and third one is the mirror networking for real-time multiplayer synchronization. Also, When a user scans an object, the data goes through Colmap and Instant NGP, which reconstruct the object into a high-quality mesh in about 1 to 3 minutes, making it ready for use by the remote collaborator. This architectural pipeline ensures that both AR and VR users are always working in a shared, interactive, visually rich environment, which is exactly what makes Virtual Nexus such a compelling platform for immersive collaboration.
Yes, so as for the methodology part, there are mainly four core components: AR side, VR side, and also a 360 video stream, and as well as a virtual replica server. So initially, this AR side, what happens is to use the Microsoft HoloLens tool and captures the environment and scans the physical objects. While the VR side is taken by the MetaQuest 2, it receives the live video and interacts via environment cutouts and also virtual replicas. For the 360 video stream, what would we use is to use the Insta360 camera and take an spatially aligned AR mesh and using QR codes. And finally, a virtual replica server would be made, and it uses instant NEB to reconstruct and see 3D models in real time. So the key features of virtual nexus, what we'll be doing is to first the environment cutouts would be made, and it is done using VR users, and the users would select the parts of the CD 3D live images and use them to interact with up close. And then we would be using the spatial mesh embedding, and this would enhance the 360 video by using invisible 3D structures. For virtual replica creation, the AR users can scan the object, and as well as the server reconstructs them using NERF, and they are shared instantly across both the users. And finally, it has a feature of synchronized interaction. So features like as ray pointers, annotations, and as well as virtual object manipulation are all mirrored in real time.
Application scenarios. The authors demonstrated 3 real-world applications where these virtual tools can be equipped and modified to work with. First one is the collaborative prototyping, where users can co-create the scene using geometric shapes and scanned models, useful for architecture, game design, and other storytelling works that can be done with collaboration. Next is a remote education. As we can know, the teacher and the student who can be able to communicate with the AR VR streams using the whiteboard as AR and VR persons on the board poster. He can answer the question, annotate the responses like that. So it will be helpful in the remote education. Third one is we can see as we said in the here review there recreation activities. They shared a VR bowling game where both just throw a virtual ball to knock down the pins. This showed how we can use this application in the real world, including the 3 examples. Results and findings from the new study, VR is found cutouts intuitive and effective, which means the cutouts plan was successfully evaluated the mean score of 4.5705. It's a very good thing. We can improve this. Well, both AR and VR users strongly agree that scanned objects enhance collaboration, which means when the virtual replicas using the instant GP they used to create the model of the real world objects as in the replica in the virtual life. So they have to feel the collaboration to work together as a feeling with another person in the same place. Arts may appreciate the natural interaction, reduce confusion, and increase precision, which is very helpful for the collaborative works. The key feedbacks involved was it felt like we were actually present in a room. It's a very good thing. Another thing was that creating a miniature version of the scenes helped me interact more comfortably. As we can see there, it's a miniature version which will be pulled down or go, go away. It's a creative miniature version which helps to easily move and comfortably they can interact the scene. As a conclusion, Virtual is an innovative AR/VR collaborative platform that combines 360 video with a sparse interactivity. Here, the 360 video with a sparse interactivity is the main aim of this project to be achieved. It introduced two powerful concepts as we seen earlier, in-memory cutouts and with real-world virtual replicas. These are two main things we have discussed earlier also. In-memory cutouts help the, both the users to enable replicas and also the virtual replicas help them to work actively. User study confirms effectiveness in improving the presence, clarity and collaborative capabilities, and this is a conclusion of the project. Thank you.